Now we start exercise 2.4. Before we start exercise, we first explain the chain rule of differentiation. Suppose that we have to find a derivative of two functions f of x and g of x, and they are both differentiable. And if y is equal to in the form of composite function like f of gx, which can be written as f g of x, then to find derivative of such a function, we'll be applying like this: dy by dx is equal to, we apply derivative whole of this expression, so that will become f into g of x derivative. This dash will be applied, or this prime will show a derivative of this whole function. So to find the derivative of such a function, we actually apply derivative first in outer layer. Means we apply derivative first on f, so that will become f prime, and g of x will be as it is. And then we apply derivative on the inner layer or inner function, which is actually g of x, then that will become g prime of x. So this is actually a chain rule where we apply just like a chain in our derivatives. First we apply derivative on f, and then derivative will apply on g of x, so that is actually like a chain. This can be elaborated in another way. Let u is equal to g of x. Let this function, the inner function, can be named as g, and y will becomes f of u, so that y was f g of x. When we let g of x as a u, so that will become f of u. Now differentiating 2 and 3 with respect to x and u respectively, as we have u is equal to g of x, so we can say u is a function of x, so derivative will apply on u with respect to x. Or you can say u is a function of x, then whenever we are going to calculate the change in u, then that will be differentiate with respect to x. So that we mentioned here that differentiate 2 with respect to x, so that will become du of dx is equal to g prime of x. And as y is the function of u, then when we apply a derivative on this function, so that will become dy by du, because y is a function of u. Whenever we want to calculate a change, so y will be changed with respect to u, so that will become dy by du, and on right hand side that will become f prime of u. Thus 1 can be written as 1 is actually dy by dx f prime g of x and g prime of x. G prime of x is actually du by dx, and dy by dx is equal to f prime of u. So 1 is actually dy by dx is equal to f prime of u du by dx. So when we put the values, f prime of u was dy by du, so that will become dy by du in place of f prime of u, and then du by dx will be as it is. So that is actually our chain rule, in which derivative dy by dx is equal to dy by du, a first derivative, and then derivative of u with respect to x, that is actually du by dx. So by joining these two derivatives, we calculate our required result, which is dy by dx. This process can be explained by using our questions. So question 1 is find dy by dx by making suitable substitutions in the following functions defined as. So our first part is y is equal to square root 1 minus x over 1 plus x. We already calculate a derivative of this function in exercise 2.3, but now we apply derivative on this question by making suitable substitutions or by using chain rule. Solution given that y is equal to square root 1 minus x divided by square root 1 plus x. Let t is equal to 1 minus x divided by 1 plus x. Then y will become, as we substitute this whole function as t, so that will become t square root, and square root will become power 1 by 2. So we have y is equal to t 1 by 2. Now we have to actually calculate dy by dx from here, but now y is the function of t, so change can be calculated with respect to t, but t is the function of x, and so finally we have to calculate dy by dt from here, and from here we can calculate dt by dx, and then by joining these two derivatives we will form our required result, which is actually dy by dx. So differentiate t with respect to x. T is actually 1 minus x over square root 1 over 1 plus x. So that will become dt by dx by using our quotient theorem, as we already solved in exercise 2.3. So applying quotient theorem here, 1 plus x whole square. This 1 plus x will be as it is, derivative will apply on 1 minus x minus 1 minus x, and derivative will apply on 1 plus x. Now 1 plus x, derivative will apply on both of these two terms, as 1 is the constant, so that it will become 0, and derivative of minus x will become minus 1. Minus 1 minus x will be as it is, and derivative will apply on 1 plus x, so derivative of 1 will be 0 and derivative of x will be 1. By simplifying these results, that will become minus 1 into minus x, minus 1 minus and minus will become plus x, this minus x, this plus x will be cancelled out, so finally we have minus 2 divided by 1 plus x whole square, which is actually our dt by dx. Okay, as y is equal to t raised to the power 1 by 2, so now we have to calculate derivative of y, and y is the function of t, so we have to calculate dy by dt, as y is the function of t, so there will be change with respect to t. Now differentiate y with respect to t, that will become dy by dt is equal to, we use our power theorem, so that will become 1 by 2 t raised to the power 1 by 2 minus 1, which will be minus 1 by 2. So using chain rule, as we mentioned earlier, that we have two derivatives, dy by dt and dt by dx, and by joining these two derivatives we will form our required derivative, which is dy by dx. So by using chain rule, that will become dy by dt, and then derivative of t with respect to x, dt by dx. We have already calculated these two derivatives, so just substitute these values. That will become 1 over 2 square root of t, which is actually this one, 1 by 2, and t 1 by 2, which can be written as 1 by 2 square root of t, which is this one, into derivative of t with respect to x, that will be minus 2 over 1 plus x whole square, 1 over square root of t multiplied by minus 1 divided by 1 plus x whole square. As we substitute t 1 minus x over 1 plus x, so just replace the values of t into minus 1 over 1 plus x whole square. That can be written as 1 over 1 minus x raised to the power 1 by 2 and 1 plus x raised to the power minus 1 by 2, as this is in denominator, into that is actually a same function, minus 1 over 1 plus x whole square. As there is 1 plus x and 1 plus x are the same basis, so we can combine these two powers. Minus 1 square root 1 minus x into 1 plus x minus 1 by 2 and 1 plus x raised to the power 2, minus 1 over square root 1 minus x 1 plus x, these two powers are combined in the form of 2 minus 1 by 2. Now simplifying these power, that will become 3 by 2, and 1 minus x was as it is, So this is our required derivative dy by dx by using substitution method or by using chain rule.